Hi, my name is Tina, and this is my project based on the unit circle. To start off the lesson on the unit circle, we begin with a brief outline of a circle split into 4 equal parts, like what we would see in a regular graph. The word unit equals 1, which tells us that the distance from the origin to any point on the circle is 1, which makes the radius equal to 1. If this were to be imagined as a regular graph, the x value on this point would be 1 because it moved to the right 1 unit, and the y value would be 0 because it did not move up nor down. Towards the top of the origin, the x value would be 0 because it did not move right nor left, and the y value would be 1 because it moved up 1 unit. Over to the left, the x value would be negative 1 because it moved to the left 1, and the y value would be 0 because y did not move at all. And finally, here on the bottom of the origin, the x value is 0 while the y value is negative 1. Now that we have that down, we can now move on to angles on the unit circle. What we need to know is that if there were to be a positive angle, we would be moving in a counterclockwise direction, whereas if there were to be a negative angle, it would be moving in a clockwise direction. Let's go into drawing positive angles, which would look something like this. The term theta is used to represent an angle without knowing the exact degree like the one we have here. In order to find the coordinates of where this angle intersects in the unit circle, we would draw an altitude connecting the point of intersection to the x value. This will create a right triangle. Since this is a positive angle, we would start here on the initial side and create a curve to the terminal side in a counterclockwise direction. This here will measure out the positive angle theta. Now let's focus on the point of intersection. Our goal here is to have a deeper understanding of the connections that link the unit circle and trig functions together in order to find the coordinates of intersection. Let's just start off by giving this coordinate the name A, B. Now onto the side lengths of the triangle. Since the radius is 1, we already know that the hypotenuse side is also 1 because it is the distance from the center to a point in the circle. The side opposite to theta is the value of y, as you can see here, whereas the baseline is the value of x on the coordinate. Now that we have labeled the side lengths, let's try to figure out how to find the cosine of theta. As we know, the cosine is adjacent over hypotenuse. For the angle that we have drawn, the adjacent side is a while the hypotenuse is 1. This makes the cosine of theta a over 1, also equivalent to the x value. As to finding the sine of theta, we know that sine is opposite over hypotenuse, which in this angle, the opposite side is b while the hypotenuse is 1. This makes the sine of theta equal to b over 1, also known as the y value. Now we can set up a new definition of trig function that will work for any angle in the unit circle. We can conclude that cosine of theta will always equal to the x coordinate where the terminal side intersects the unit circle. The sine of theta equals the y coordinate where the terminal side intersects the unit circle. And that leads to tan, where it makes sense to say that tan of theta equals sine of theta over cosine of theta, also equivalent to y over x. This method can be used to find the coordinates of a 45 and 30 degree triangle. Examples. In this example, we see that the angle is 45 degrees. First, we start off by making it into a triangle. Since this is a 45, 45, 90 triangle, we can use the special right triangle rule to find the value of each side length. Since the radius is 1, we know that the hypotenuse is also 1. Over here, we see that the hypotenuse is x times radical 2, so in order to find x, we divide 1 by radical 2, which will result with x equals 1 over radical 2 simplified to radical 2 over 2. Now we can plug what we found into the special right triangle. The height and baseline both equal to radical 2 over 2 because in a 45, 45, 90 triangle, those sides of the triangles are the same. As we know, the sine of theta equals y and the cosine of theta equals x. So if we look here, the sine of 45 is radical 2 over 2, which makes it the y-coordinate where the terminal side intersects the unit circle. The cosine of 45 in this angle is also radical 2 over 2, which equals the x-coordinate where the terminal side intersects the unit circle. This makes the coordinates of angle 45 positive radical 2 over 2 comma radical 2 over 2 because 45 degrees is in between the angles 0 and 90. To find the x and y coordinates of a 30-degree angle, we can start by creating a triangle by connecting the intersections of the angle to the x-axis. Here we have a 30, 60, 90 triangle. In this type of triangle, the hypotenuse is twice the value of the side opposite to the angle of 30 degrees. We know that the hypotenuse is equal to 1, which makes the side opposite of 30 degrees 1/2. Because, as said before, the hypotenuse is twice the size of the height. To find the last side, we multiply 1/2 to radical 3, which will get us radical 3 over 2. Now to find the x and y coordinates, we will now use trig functions. The sine of 30 is 1/2, which we know is the y value since sine of theta equals y. The cosine of 30 is radical 3 over 2, which will make the x-coordinate radical 3 over 2. In conclusion, the coordinates of angle 30 is positive radical 3 over 2, comma positive 1/2 because 30 degrees is in between the angles 0 and 90.